So we're going to have a look at another dynamics question. Here we're asked to use work and energy to calculate the terminal velocity of a 100 kilogram object released from a height of 320 meters. So we know the distance the thing travels is 320 meters. It is a mass of 100 kilograms. We know that work is force times distance. So in this case, work is going to be the force exerted on the object. Well, there's only one in this case. We are going to ignore wind resistance. So the only force is gravity. So this is mass times gravity times the distance. So we have the work is 100 times minus 9.8 times the distance. We could make this minus 9.8 plus 9.8 because really we only care about the absolute value of the work, but we'll leave it as negative in this case because we are moving down. This distance is 320 meters. So this gives us 100 times 320 times minus 9.8. So the work is minus 313,600, and that is joules. So that's the answer to the first part that we need here. We needed to find how much work was exerted on the object as it moved down. The work was done by the gravitational field, incidentally. But from the perspective of the object, it's negative work. From the perspective of the gravitational field, positive work. So what is the terminal velocity? Well, we know that when it starts, its potential energy was greater than 0, and its kinetic energy was 0. Once it hit the ground down here, its potential energy was 0, and its kinetic energy was greater than 0. So all of the potential energy was converted into kinetic energy. How much energy? Energy equal to the absolute value of the work. So we know kinetic energy is 1/2 times mass times velocity squared. So if we multiply both sides by 2, we get 2 times the kinetic energy is equal to mass times velocity squared. Divide both sides by the mass. This gives us velocity, and then take the square root of both sides, is equal to the square root of 2 times the kinetic energy divided by the mass. So square root of 2 times, we're going to have the absolute value of the work here in order to make this equation actually plausible. So it'll be 313,600 divided by 100. So the velocity number we're going to get here is the square root of 2 times 313,600 divided by 100. So this gives us 79.1959. 59, ... So therefore the terminal velocity is about 79 let's say 20 meters per second to 2 decimal places. It's about 80 meters a second. So this is very, very fast. And that's the answer to the question. Now this question is a very interesting question for one particular reason outside of the actual calculation in the question. During the 9/11 terror attacks, which happened in the United States, people jumped from the 84th to 90th floors of the World Trade Centers when they were attacked. And some of these people may have thought that they would have survived. You face burning to death in the building, or you jump out the window. Well, actually, your terminal velocity, the terminal velocity of a 100 kilogram person, remembering that these floors were about 300 to 400 meters above the ground. I believe the 84th floor was 320 meters. That's certainly where this number is coming from. So if you're a 100 kilogram person and you're jumping off the 84th floor, you are hitting the ground at a velocity of 79.2 meters a second. That is incredibly, incredibly fast, right? That is overwhelmingly enough to kill you instantly on impact, right? And that is in fact what happened when people jumped out of the buildings. When they hit the ground, that is such a high terminal velocity that they were literally blown into pieces.